And there's three main key features that we want to talk about. One of them is growth or decay, the horizontal asymptote specifically, and the y-intercept. And so let's start with if something is growing or decaying. We always read our graph from left to right, and so if something is growing, I should be increasing the same way I would in a linear, the same way I would in a quadratic. I should see some sort of increasing. So if I'm looking at this first graph and we're showing a growth and a decay in both this plane here, just so you can see an example. So the top graph right here, as we can see, it's increasing because it's going up. That represents a growth graph. All right. And so if we read from left to right, that bottom one is represent a decay graph, and as you can see, it's like decreasing or going down. There's a lot of words that start with D that describe decreasing. Okay, decrease, decay, down, you name it. All right. The asymptote. So the asymptote is where the line is approaching, but it never goes underneath. So it just kind of depends on the graph, and we're going to look at some of the examples here just to identify the horizontal asymptote. But the horizontal asymptote for this one is this dashed line. It's a little bit hard to see because it's on the x-axis, because in this case the horizontal asymptote just happens to be 0. And so what that means is the graph will never go below where y equals to 0. And how we know our equation is going to start with y equals is because, remember, wherever our line goes, whichever axis our line goes through, that's exactly what our equation is going to start with. So the horizontal asymptote goes through the y-axis, so that's why it's going to be y equals to 0. Again, we'll look at a few examples. Just like a linear and a quadratic, exponentials also have a y-intercept. It's the same concept. It's going to be where the function crosses the y-axis. So in our growth, we have it 0, 1. In our decay, we're at 0, negative 1. Let's get into our first example. So example like this, we want to see which statement about this graph is not true. And so what I want to do is I want to use this equation right here to give me a better of a visual, because we want to know three things. Is it growing or decaying? What is the horizontal asymptote? And what is the y-intercept? So let's go ahead and go to Desmos. I'm going to go ahead and do a split screen really quick. And I'm going to type in that equation. So I have y equals 16, open parentheses, 0.5, close parentheses, shift 6 to the x power. And as I can see right now my exponential equation. All right, so first of all, first things first, am I growing or am I decaying? So if I read from left to right, it looks like my graph is going down. So I can easily say that this graph represents decay. On your notes for me, go ahead and add on your notes that picture really quick. So we're going to make sure we touch the y-axis as well. And it's going to be doing like that. So we know right here, this is the y-intercept spot. So if we look on our Desmos, we can see exactly where the line is going to cross. Y'all see that gray dot? That gray dot helps you. So right now, we know our y-intercept is at 0.16. So our y-intercept is at 0.16. So that's what I'm putting right here. My y-intercept is at 0.16. That's why I love Desmos. It'll even show you. So now with asymptote, as you can see with asymptote, you see how the red line is touching 0, well, where y equals to 0. So let me go back. Where y equals to 0, that's where the line is touching. But notice how the line never goes below y equals to 0. So that's going to be our horizontal asymptote. And I'll go ahead and zoom out so you can see that it doesn't matter how far you go, it's still going to be, it does never go underneath the 0. So that means our asymptote, horizontal asymptote, is where y equals to 0. All right, let's check out the next example together. All right, so here we go. So without using Desmos, we're going to go ahead and make this back bigger so we don't need it anymore. So without even using Desmos, I'm going to read from left to right. And I see myself going up, Up sounds like a good thing. I know that that is growth. So let's go ahead and write on our notes. This is indication of growth. Horizontal asymptote. So if I follow it, I'm looking to see where on the y-axis is it going. Again here, it's never going to go underneath 0. So our asymptote is y equals to 0. And now we're going to look where our y-intercept is. And it looks like it's somewhere right here. That's where the line touches the y-axis. And there is a 1. So I know 1 goes in the y spot. So that means 0 goes into the x spot. And so my y-intercept is at 0, 1. Go ahead and try that next example on your own, and then we'll continue. All right, so here we go. Let's look at the next example, last one of the day. I read from left to right, so if I start from my left, I'm actually going down. So that is an example of decay. All right. My horizontal asymptote, again, it's still approaching where y equals to 0. It'll never go underneath. I know you're probably wondering, is the asymptote always going to be y equals 0? Not always, but in these examples, they have. All right, so we always just want to make sure we want to see where does the line never go under on the y. Okay, so it's never going to go underneath the 0. My y-intercept, this is where the line, right here, this is where the line is touching the y-axis. So between 2 and 4 is a 3, so I'm filling my 3 spot. So I know 3 is going to go in my y spot for y-intercept, and 0 is going to go in my x spot. All right. We have now identified growth, decay, horizontal asymptote, and y-intercept from exponentials. I'll see y'all next time.